Now, the next two problems are very similar. And again, if you ask me how I would approach these problems, here is what I would do. I would first of all remind you about how to construct right triangles on the XY axis. So for instance, we know that this is 0, 90, 180, 270, and 360. Or 0, pi over 2, pi, 3, pi over 2, and so on. If you want to construct a right triangle in any quadrant, what you want to do is you want to draw an X. You want to connect them. Draw your 90s, and then draw your thetas. So if they say quadrant, this is quadrant 1, quadrant 2, quadrant 3, and of course this is quadrant 4. So if a problem says something like 90 less than X less than 180, between 90 and 180, that is describing quadrant 2. If somebody tells you, hey, 270 less than X less than 360, between 270 and 360, here's 270, here's 360, aka 0. They're describing quadrant 4, so I would draw a triangle like this. So for a problem like this, notice they're describing that your angle X is between 90 and 180, which means that we should go to 90 to 180, that means quadrant 2. So we draw this model here to help us out. So this is how I always do these problems. I make models. The models really help us, and that's what it should look like. Now, label your sides. This is the hypotenuse, and then across your angle, shoot across your angle. This is your opposite, and this is your adjacent. We remember these words, yes? Hypotenuse, opposite, adjacent. The hypotenuse is always the one that's crooked. The opposite and the adjacent are the ones that form an L, where the opposite is across your angle, and then process of elimination is this guy. So, remember, SOHCAHTOA, okay? I want to find the three sides of this triangle because the three sides are going to help me with my goal. So, tangent is given to you for free. And remember that tangent is opposite over adjacent, SOHCAHTOA. So opposite is the numerator and adjacent is the denominator. So my opposite, which has been labeled, my opposite would be 3 and my adjacent would be 4, but it's going to be negative. If you go to the right, that's positive. If you go down, that's negative. So if you go left, that's negative. If you go left, that's negative. If you go up, that's positive, and so on. Now, we need the hypotenuse. So let's go Pythagorean Theorem. A squared plus b squared equals c squared. The legs are a and b in any order. So 3 can go in for a or b, doesn't matter. Negative 4, a or b, doesn't matter. Just make sure the hypotenuse is always c for sure. Just put the hypotenuse in for c, and everybody else can go wherever. So we have 3 squared, like that. If you work out the math, you're going to get that the hypotenuse is 5. Now, by the way, the hypotenuse is never negative. Only the legs could be possibly negative, depending on the direction. Hypotenuse is always positive. Now that we have a diagram completed, we're ready to rock and roll. First part, sine of 2x. We need sine of 2x. How do I deal with the 2? Because I know SOHCAHTOA is for sine, cosine, and tangent, but that's not sine, that's sine of 2x. So remember, in your double angle formulas, that sine of 2x equals 2 sine x cosine x. So that helps us out. So we know that this equals 2 times sine x times cosine x. So what we have to do is take a time out and work over here real quickly because we need to find sine of x and we need to find cosine of x. I need to find this and I need to find that. So sine is, if you remember SOHCAHTOA, sine is opposite over hypotenuse. So sine equals the opposite, which is there, over the hypotenuse, which is there. That's why a diagram is so clutch, because it helps you with SOHCAHTOA. What about cosine? Cosine is adjacent over hypotenuse. So our adjacent is that, and our hypotenuse is that. So grab these numbers and drop them in here and we're done. For instance, the 2 is just the 2. Sine gets replaced by 3/5 multiplication. Cosine gets replaced by negative 4/5. Type all this gibberish into your calculator. It'll say negative 24 over 25. Final answer for sine of 2x. Now you have to do cosine of 2x and you have to do tangent of 2x, where cosine 2x is this here. So cosine of 2x has 3 different options. Pick any option, it doesn't matter, you'll get the final answer. You get the same answer for all 3 options. For cosine of 2x, you only have this option down here. So cosine 2x and tangent 2x, approach them the same way that I approached sine 2x. Okay, and then I'll let you do these parts here on your own. But let me get you started with the next